Hello students, today we are going to discuss the second important model of nuclei. First model was liquid drop model and today we are going to discuss cell model. Cell model is one of the most important and useful model. This model was developed from 1945 to 50. The development of this model takes place from 1945 to 50. And this model is very useful because with the help of this model, one can find out the spin and parity of the ground state. One can find out the spin and parity. Spin and parity of the ground state of nuclei. Second, with the help of this we can find out the magnetic moment of the nuclei. Magnetic moment of nuclei. We can also have a rough estimate of electric quadrupole moment. Electric quadrupole moment of the nuclei. Moment of the nuclei. So this model is very important because with the help of this we can find out these things. Apart from the spin and parity of the ground state, when we will extend this model, we will be able to find out the spin and parity of the excited states also. So you can say with the help of cell model, one can also have an estimate of excited state. We can also find out the spin and parity of excited states. So this is a very important model. Now, question arises how the concept of this model was developed, from where the idea of this cell model come into the picture. In between 1945 to 50, its development was taking place. Basically, these nuclear scientists, they were observing remarkable basically these nuclear scientists were observing the remarkable discontinuities in nuclear properties. Continuities in nuclear properties when number of neutrons or number of protons becomes equal to 2, 8, 20, 50, 82 and 126. So what they were observing, that the properties are remarkably changed. There is a sharp discontinuity in the properties of the nuclei when number of protons or number of neutrons, their number becomes equal to 2, 8, 20, 50, 82 and 126. Apart from this, they have also find out that the nuclei with number of proton or neutron equal to 14, 28 and 40. Nuclei with these protons or neutron number, they are also showing extra stability. Here, nuclei with these proton and neutron number, they are highly stable, and even these nuclei are stable as compared to the neighboring nuclei, but they were less stable with those nuclei having N or Z equal to these number. So this was a very important result, and these numbers, later on these numbers are known as magic numbers. You will know that they are known as magic numbers, and these numbers are known as semi-magic numbers. They are known as semi-magic numbers. So people were observing the different properties of the nuclei by varying A number as well as Z number, and they observed that whenever the nuclei achieve these proton and neutron number, their properties becomes very much discontinuous from the regular pattern. So on the basis of this, to explain these numbers, why nuclear properties are changing, they are showing discontinuity at these numbers, they revisit the electronic structure of an atom, and from this they try to explain these numbers by assuming that inside the nuclei, these protons and these neutrons, they are also arranged in some type of cell structure, and whenever a cell is completed, that completed cell will provide extra stability to the nuclei. So from this they concluded that when the number of proton and neutron becomes 2, 8, 20, 50, 82, 126, it means their cell structure is closed. And whenever nuclei has a closed cell structure, their outer cell is completely filled, then that type of nuclei will be extra stable, and its property will be more different. Its property will show discontinuity. Their properties will be remarkably different from its neighbors. So they to explain these magic numbers and semi-magic number, they came to the conclusion that inside the nuclei, these protons and neutrons, they are arranged in some type of cell structure. So these neutrons, number of these neutrons, you can say, from this they conclude that neutrons and protons inside the neutrons and protons inside the nuclei are arranged in some type of cell structure. Now to support this claim, so now they are claiming on the basis of these numbers, they will try to define these numbers. They want to justify these numbers on the basis of some type of cell structure inside the nuclei. But for this they need some experimental support. So there were certain evidences. They find out certain experimental evidences of the cell structure. So to support this claim, they find out certain experimental evidences which supports the cell structure. So evidences which are supporting, now I am going to discuss various evidences which supports or which indicate towards the cell structure. So few experimental evidences in support of cell structure. So what are the experimental evidences in support of cell structure? First and most important evidence of the cell structure was find out if you plot average binding energy of a nuclei versus A number. If you support average binding energy versus A curve, if you plot this curve, then you will observe that the nuclei with magic numbers, nuclei with Z or N equal to magic number have very large value of average binding energy. So basically average binding energy, so when you plot this type curve, then you will observe that average binding energy increases suddenly when N or Z becomes equal to magic number. So whenever N or Z becomes equal to magic number, you will find out that the average binding energy of the nuclei suddenly increases. You will find out a remarkable change, remarkable increase in the average binding energy. This was the first evidence they have provided. Second evidence was that we have 4 radioactive series. We have 4 principal radioactive series here. Second evidence was in terms of radioactive series. We have 4 radioactive series. First is thorium series, neptunium series, you are aware about this series: thorium, neptunium, uranium series, thorium, neptunium, uranium and actinium. These are 4 principal radioactive series. Actinium series. These series are also known as, this is also known as 4N series. This is known as 4N plus 1 series. This is known as 4N plus 2 series. So what they were observing here in all the 4 series, they were observing their end product. What is the end product of these 4 series? And they observe that for the thorium, this is 82 Pb208, 82 Pb208, and this will be 126. This is number of proton, number of neutron, and this is A number. So what here they were observing that this number 82, this is a magic number, and this number is also a magic number. So what they were saying, that the most stable nuclei, the stable nuclei at which this series ends, basically this carries number of protons and neutrons equal to magic number. So these protons and neutrons, they are providing extra stability to the nuclei, and all the end products of all these 4 series, you will find out either their proton number or their neutron number, or both proton as well as neutron number, they are magic number. So these extra stable nuclei, which are the end product of these 4 series, their proton number or neutron number or both proton and neutron number are magic numbers. This series, second series, terminate at 83 Bi, and this will be 209 and this will be 126. So here this will be 126. This is a magic number. 126 is again magic number. For this uranium series, this is 82 Pb206. This is 82 Pb206. So this will be 124. This will be 124. So this will be basically here 82 is the magic number. So here you will observe that either proton or neutron or both, they are magic numbers in the end product of these series. And in case of actinium, this is 82 Pb, this is 82 Pb 125, and this will be 207. So here this is a magic number. So in all the four series, end product which represents the stable nuclei, this carries proton or neutron number equal to the magic number. So these numbers are providing the extra stability. So one can also confirm that there can be some type of cell structure inside the nuclei. This was the second important thing. Another important thing which is providing an insight about the extra stability of these nuclei was that the number of stable isotones is maximum 4. Number 3 is number of stable isotones. Number of stable isotones are maximum. For nuclei having n number equal to 50 or 80. N number equal to 50 or n number equal to 80. So here number of isotones with nuclei having n number equal to 50 is 6, while the nuclei having n number 80, this type of isotones are 7. So this is the maximum number. So maximum number of stable isotones are associated with the nuclei having n number equal to 50 and 80, which are magic numbers. So this is also providing an evidence about the extra stability of these nuclei. The another evidence is that most stable or most abundant nucleids in universe are 2He4. Basically most abundant nuclei in the not 2He4. This is 8O16. This is 8O16. So number of neutron will also be 8. This will be 20 Ca40. Number of neutrons will be 20. Next will be 38 Sr, 88. So this will be 50 here. So these are few, and 82 Pb 208, and it will be 6, and this will be 126. So basically these are the few examples of most abundant nucleids which are present in the universe, which are observed in the universe. And here you will observe that their number, here the number of proton both are equal to magic number. Here again both proton as well as neutron, they are equal to magic number. Here number of neutrons are equal to magic number, and again here both proton and neutrons, they are equal to magic number. So most abundant nucleids in the universe are those for which number of protons and neutrons are equal to magic numbers. This is another evidence which basically provide us information about the extra stability of these nuclei. Another important aspect of this is that the binding energy of last neutron added to complete a cell of neutrons is very small. Another important fact was observed that the binding energy of last neutron to complete the neutron cells is very small. This is another important fact, because this cell will be more stable when there will be a closed structure, there will be completely filled cell. So automatically whenever you are adding the last neutron to complete the cell, the corresponding binding energy is observed very small. So all these facts, all these are the experimental facts which indirectly or indirectly these facts are indicating towards the cell structure. I'm not saying that you can get a direct evidence, but directly or indirectly somehow they are focusing these facts are focusing our intentions towards the cell structure. So these are very important experimental evidences which enlightened the nuclear scientists to think about the cell structure that will be present inside the nuclei. Now, on the basis of these experimental evidences, nuclear scientists were convinced that there is some type of a cell structure inside the nuclei. So now they want to confirm, they want to find out the cell structure, they want to develop a theory about the cell structure. So they started in a very simple way. First they consider a very simple model which is known as single particle cell model. So first type of cell model that was developed was single particle cell model. So here they have made two very important assumptions. They started this cell model in a very simple way, and for this they have assumed two important assumptions. So two assumptions were made by these nuclear scientists. First assumption was that each nucleon moves in its orbit within the nucleus independent of all other nucleons. So each nucleon inside the nuclei moves in its orbit independent of other nucleons. Actually, why they made this type of assumption? Because inside the nuclei we have many neutrons as well as many protons. So this will be a many particle system, and if you want to write down the Schrodinger equation and you want to solve that Schrodinger equation to find out the energy eigenvalues, then it will be very difficult. So they made this picture simple by assuming that inside the nuclei, every nucleon, either it's proton or neutron, every nucleon is moving independent of other nucleons. So this was the assumption made by them. But now second question arises, if this nucleon is moving independent of the presence of other nucleons, then what will happen to the interaction of other nucleons with this nucleon, as well as the interaction that is taking place in between those nucleons? Because these nucleons can be proton and neutron, and these proton and neutron, they are somehow interacting with each other either through Coulomb forces or through nuclear forces. So surely there is some type of interaction, but we are assuming that each nucleon inside the nuclei moves in its orbit independent of other nucleons. So we are neglecting that type of interaction. So where will that interaction will come into the picture? How we can incorporate that interaction between nucleons inside our model. So for this they have assumed second assumption. And what was second assumption? Second assumption is that the effect of all other nucleons is smoothened. The effect of all other nucleons, all other nucleons is smoothened. The effect of all other nucleons is smoothened, and the force on any nucleon inside the nucleus is represented by a potential well. And what they were saying, that the interaction between the nucleons is averaged out, and from that average out value of interaction in place, they replace that average out interaction by a potential well, and this potential well will represent the force. This potential well will represent the force on any nucleons due to the presence of other nucleons. Basically, every nucleon is experiencing some type of force due to the interaction with other nucleons. So what they did, they smoothened the effect of all other nucleon is smoothened. The meaning of this is the interaction between this nucleon and other nucleon, as well as the interaction between other nucleon is smoothened, or it is averaged out, or you can say this is averaged out. Averaged out, and the force experienced by the nucleon is represented by a potential well. Suppose that potential well is represented by this potential well is represented by a central potential VR. This is represented by the central potential VR. Central potential. So now our problem is simple. We are assuming that each nucleon inside the nuclei is moving independent of other nucleons, but this is moving under the influence of a potential well. And actually, what is this potential well? This potential well is representing the average out effect of the interaction between nucleons that is taking place. So now our picture is more simple. Now what we have to do, we have to substitute this value of VR in the Schrodinger equation into time independent Schrodinger equation. We will solve that Schrodinger equation and we will find out the energy eigenvalues. So now what is the next step here? We will substitute this into the Schrodinger equation. This Schrodinger equation will be del square psi time independent Schrodinger equation plus 2m upon h cross square. Here capital M is the mass of the nucleon. This will be E, which we have to calculate, minus this potential well. This is VR, in which this particle is considered, and this will be psi here. This will be equal to 0. So we have written the time independent Schrodinger equation, and we will substitute here this central potential. We will substitute here the central potential, And by solving this Schrodinger equation, one can find out the energy eigenvalues, or the energy carried by these nucleons in different cells, which will be present inside the nuclei. From the quantum mechanics, we know that the solution of this will be like this. This psi here, there will be 3 quantum numbers n, l and m. This will be a function of r, theta and phi. This will be equal to a part, radial part. This will be ur upon r, or you can say unlr. This will be the radial part of the solution. And second part will be the spherical harmonics. This will be written as Lm theta phi. This is known as the spherical harmonics. So there will be 2 parts of the solution of the Schrodinger equation. So in quantum mechanics, we have solved this type of equation where Vr is the central potential. Then solution of this will be like this one. Here, this Ylm theta phi, this is known as the spherical harmonics. But because here we are assuming that the potential is central potential. Because here we are assuming that the potential is the central potential, so no directional part is needed. So due to this reason, there will be no need of directional part. So there will be no need of directional part. So we will solve this time-independent Schrodinger equation only for the radial part. So here we are going to solve the Schrodinger equation for the radial part only, because this potential we are assuming that is the central potential. So there is no need for this. There will be a symmetry for theta and phi, so there will be no need for this. So now different type of potential were chosen by the people, by the scientists. 3 most important potentials which were chosen by the nuclear scientists are: first type, or the simplest type of potential that was chosen by the nuclear scientist was the infinite square well potential. So first potential that was chosen by the scientist was the infinite potential well. This was the first type of potential that was chosen by the scientists. Here Vr was equal to 0 for r less than r, and it was infinity for r greater than r. This type of potential, first time they choose this potential, Vr equal to 0 for r less than r, where r is the radii or radius of the nuclei, and it will be infinity. This is infinity for r greater than. So they were considering infinitely sharp edges. Here they were considering infinitely sharp edges. They substitute this Vr here in this equation, they solve this and find out the Schrodinger equation, find out the energy eigenvalues. After this, I'm coming to the point what will happen here. Second type of potential they choose was the spherical harmonic potential, harmonic or oscillator potential. Well, second potential they choose, that was harmonic oscillator potential well. This was another important potential that was chosen by the people. Profile for this was simple. This was Vr. This was equal to minus V naught plus 1 by 2 m omega r square. So this type of potential, m omega square r square potential. This potential was like this. This potential was like this. This is R. Here we have V. So potential was like this. This type of potential, this was minus V naught, this is 0. So this type of potential was chosen by them. They substituted this potential here, they solved this Schrodinger equation and find out the energy eigenvalues. Another important potential that was chosen by these people was the Wood and Saxon potential. The third important potential which was substituted in the Schrodinger equation was given by two scientists. Their name was Woods and Saxon. Third type of potential they choose, that was Woods and Saxon potential. Saxon potential. Its profile was like this. Its profile was VR is equal to minus V naught upon 1 plus exponential R minus R upon A. This type of potential was chosen by these two scientists, Woods and Saxon potential. They substituted this potential in the Schrodinger equation. They solve the Schrodinger equation and find out the energy eigenvalues. Here if you plot this potential, shape of this potential will be like this. The shape of this potential will be like this. This type of shape this potential have. Here this will be minus V naught and here this will be R. So this type of potential was chosen by people. These are the three important potential that people choose. They substituted these potential in the Schrodinger equation. They solve the Schrodinger equation and find out the energy eigenvalues. Here I want to give you some parameters like this capital R, radius of the nuclei. This will be given by R equal to R naught, A to the power 1 by 3. Where this A is equal to 0.52 Fermi, and another is this V naught. This will be nearly 50 MeV. These are the typical parameters for this Wood and Saxon potential. But when people substituted these values inside the Schrodinger equation, when they substituted these values of potential inside the Schrodinger equation, they were able to find out only few magic numbers. What are the magic number? 2, these are the magic numbers. These are the 6 magic number: 2, 8, 20, 50, 82, 126. But when they substituted these three potential inside the Schrodinger equation, they find out energy eigenvalues, and they plotted the different cells, but they find out that they are able to obtain only these first three magic numbers. With the help of these three potentials, they were able to find out only these three magic numbers. I'm not going in detail with everyone, but I'm going to explain how these cell structures are created with the help of this example of harmonic oscillator potential well. Suppose I'm taking this example, you can take any one, but here I'm choosing this harmonic oscillator potential well problem because when they introduce this potential inside the Schrodinger equation, they find out energy eigenvalues. What this potential was providing, this was providing us the degenerate energy levels. This was the important aspect that was introduced by this harmonic oscillator potential well. So in harmonic oscillator potential well, people were getting degenerate energy levels. So I am going to discuss only this part and not in detail. I would just want to give you an idea how these energy levels are created with the help of harmonic potential valve. So now come to this harmonic oscillator potential valve potential. When we substitute this inside the Schrodinger equation, we find out the energy eigenvalue given by ENL. We find out these energy eigenvalues. ENL is equal to lambda plus 3 by 2 H cross omega, where this lambda was equal to 2 times n minus 1 plus L, where value of lambda by this. When you substitute this harmonic oscillator potential valve potential VR in the Schrodinger equation, you solve that Schrodinger equation, then people find out this type of energy eigenvalues, where this lambda can have values, it can have value 0, 1, 2, 3 like this. You are already aware about these things. You have studied all these things in your quantum mechanics course. So from this, how we will create different energy levels? How can you create different energy levels? I am going to discuss with you. Suppose, so energy eigenvalues are lambda plus 3 by 2 H cross omega. So first, what can I write here? I can substitute lambda equal to 0. When you substitute lambda equal to 0 here, then energy of lowest energy level will be equal to 3 by 2 H cross omega. So here, what we are having, this is the lowest energy level. Its energy is 3 by 2 H cross omega, and it is corresponding to lambda equal to 0. When we are taking lambda equal to 0, we will get the first energy level. Now substitute the second one. Substitute lambda equal to 1. So you will get the next energy level. Its energy will be 5 by 2 H cross omega. After this, take lambda equal to 2. It will be 7 by 2 H cross omega, its energy. They are equally spaced. These energy levels, they are equally spaced. Separation between these energy levels is H cross omega. Separation between these energy levels is H cross omega. Next is lambda equal to 3 here. We will have lambda equal to 3. This will be 9 by 2 H cross omega. Next will be lambda equal to 4. This will be 11 by 2 omega H cross omega. I am writing this expression here. This will be ENL. ENL will be equal to lambda plus 3 by 2 H cross omega, where lambda is 2 times n minus 1 plus L. This is the value of lambda, and lambda can have value 0, 1, 2, 3 like this. So I am removing this. Next energy level will be corresponding to lambda equal to 5. This will be corresponding to lambda equal to 5. This will be 13 by 2 H cross omega. Next energy level will be this one. This will be lambda equal to 6. This will be 15 by 2 H cross omega. So this type of different energy levels will be present according to the harmonic potential valve solution. Now this is lambda. Now lambda is equal to 0, 1, 2, 3. Corresponding to this, we find out these energy eigenvalues. Now n will start with 1. Now we can choose n equal to 1. Now corresponding to n equal to 1, L can be 0, 1, 2, 3, 4, like this. If we substitute here, if I substitute n equal to 1, if I substitute n equal to 1, L equal to 0. Here n equal to 1, L equal to 0, then this lambda will be 0 and it will be 3 by 2 h cross omega. So here, so n equal to 1, L equal to 0, this is corresponding to 1s energy level. L equal to 0, basically this is 0 is corresponding to s orbit, this is corresponding to s, p, d, f, g, h, I. These are the values of L values for different orbits. So n equal to 1, L equal to 0 is corresponding to 1s orbit. What will be the energy of this 1s orbit? It will be substitute n equal to 1 here, L equal to 0 here, so lambda will be 0. So this will be lambda plus 3 by 2 h cross omega. So this energy level is corresponding to 1s. Now find out this n equal to 1, L equal to 1. This is 1p orbit. What will be the energy of this? This will be 1 minus 1, 0. So this will be 1 here. 1 plus 3 by 2. This will be 5 by 2 h cross. So this is corresponding to, this is the energy of 1p orbit. Energy of 1p orbit is 5 by 2 h cross omega. Similarly, you can find out for 1d. This will be L equal to 2. So this will be 1d orbit. If you substitute n and L here, find out lambda, substitute here. This energy comes out to be 1d. This will be 1f, 1g, 1h and 1i. These are basically these orbits, these suborbits 1s, 1p, 1d, 1f, 1g, 1h, 1i. They are having this much amount of energy. Now come to n equal to 2. Now come to n equal to 2, L equal to 0. So this will be 2s orbit. This will be 2s orbit. Substitute this value here. L is equal to 0, 2 is 0, 2 minus 1, 1, this will be 2. So this will be 2 plus 3 by 2. So this will be 7 by 2. This will be 7 by 2 h cross omega. So here this 2s orbit will have energy is equal to 7 by 2 h cross omega. If you find out for 2p, n equal to 2, L equal to 1, this will be corresponding to 2p. If you calculate the energy corresponding to this, here this energy will be 9 by 2 h cross omega. So this is the energy of 2p. So 2p will be corresponding to this energy. Here this will be corresponding to 2d, 2f, 2g, like this. This type of energy level is obtained. Now if you go to n equal to 3, if you go to n equal to 3, L equal to 0, then this will be corresponding to 3s. If you calculate the energy of this, this will be 3 minus 1, 2, 2 to the 4. So lambda is equal to 4. So 4 plus 8 or 3, 11. 11 by 2 h cross omega. So this is the energy of 3s. This will be the energy of 3p. This is the energy of 3d. And next will go on. It will go on. If you calculate for 4p, then for 4s, it will be here. So here this type of cell structure was obtained if we assume that inside the nuclei there is a potential, there is an average out potential whose shape is harmonic potential type. If its shape is harmonic potential type, then we will find out these energy levels. And here you will find out that there is a degeneracy. This level, this is 7 by 2 h cross omega energy level, but both these sub levels, this 2s and this 1d, both have this energy, equal energy, 7 by 2h. So they are known as degenerate energy levels. Their energy is equal. However, their n value and l values are different, but they are representing the same energy level. So there is a degeneracy that is introduced here. Now after this, now you calculate, or you will now you can find out the number of protons or neutrons you can fill in these energy levels. How many protons or neutrons you can fill in these energy levels. So I am removing this lambda. Now come to this 1s. In 1s, how many number of protons or neutrons, what will be the maximum number of protons or neutrons can be in 1s sublevel? This will be just 2. Inside this we can have only 2. So this level will be completely filled if in this level either we have 2 protons or we have 2 neutrons. This is the second. This is 1p. In p level we can have maximum number of proton and neutron. This is 6. Here in 2s and 2d, in 2s, how many we can have in 2s? Maximum we can have 2 here, and in 1d we can maximum have 10. So here maximum number of proton or neutron can be 12. Here in 2p maximum number can be 6, and here in 1f it can be 14. So here it can be 20. Similarly you can write for others. For this will be 2. For D it will be 10. This will be 18. So this will be 28. This will be 30 here. Here in 3p maximum 6. In F, SP, DF this can be 14. In F this can be 14. Here it can be 22. So maximum it can be, and this can be how much maximum? 4 or to 6, 6 or 6, 12, and this will be 2, 3 and 4. This can be 42. Similarly, if you calculate for the upper one, this will be 2, 10, 18, 26. This will be 2, this will be 10, this will be 18, this will be 26. If you add up, then now these are the maximum number of protons or neutrons which can be present in these energy levels. Then first level will be completed when number of proton or neutron is equal to 2. When total number of proton and neutron is equal to, first energy level will be completed. So this is number is 2, and this is a magic number. So this is the first magic number we have obtained. This second energy level will be completed when total number of proton and neutron will be 6 plus 2. This will be 8. If total number of proton and neutron is equal to 8, then even second level will be completed, and we can obtain the second magic number. So this second level will be completed when proton or neutron number is 8. So this 8 is the second magic number. Third energy level will be completed when number of proton and neutron will be 12 plus 8, 20. How we are getting this 20? This is 12 plus 6, 18 plus 2, 20. When number of proton and neutron is equal to 20, then this third level will be completed. So in this way we have obtained the third magic number also. Now, so next will be 40, which is not a magic number. This is not a magic number. This will be 70. Next is 70. 40 is not a magic number. 40 is not a magic number. Next is 70. Then it will be 112, 112, 168. These are not the magic numbers. So with the help of this harmonic potential inside the nuclei, one can obtain only first 3 magic numbers, 2, 8 and 20. Apart from this, another important thing which we are obtaining, that is the degeneracy. that degeneracy present inside in these energy levels. Here this 2s and 1d, they have same energy. 2p, 1f, these two sublevels, they are having same energy. Here these three sublevels, 3s, 2d and 1g, they are having same energy, 11 by 2 H chromosome energy. So when we are using this type of potential, we are getting degeneracy as well as we are getting first three magic numbers. Even when we will use the infinite potential well or Wood section potential well, you will achieve only these three magic numbers, 2, 8 and 20. We are not getting the next three magic number. So from this we can conclude one thing, that we are missing something. There is something missing in this present model, due to which we are not able to obtain all the magic numbers. So something is missing. We have to find out that missing part. Something is missing.